Next is actually it's a technique you are not going to use in your actually right now, but you must be aware that as it is written that one other techniques are here that is said to be the screen printing. Screen printing techniques is mostly being used in order to make the nameplate or other things. For that purpose, it is to be used. So if you see here in this technique is a simple to operate and produces a film of uniform thickness on different substrates. In this method, a polymer solution or slurry is stressed on a dense net whose net, remember this is dense net, whose bottom is attached to a smooth metal plate as a carrier. Uh, so dense net whose bottom is attached to a smooth metal plate as a carrier. Now a squeezer is passed over the slurry with some force, causing the slurry to flow through the net and form a uniform thin membrane in metal plate carrier. After drying, after drying, the thin film is taken off from the carrier. It shows the screen printing techniques for the silver paste coating on substrate. The thickness of film depends on the solution viscosity, mesh diameter of the net, applied forces on squeezer, and the velocity of squeezer on the metallic plate. So the above process is good with uh, what happened? Whose mic is on? Who was there? Students? Among yourself, someone mic on just before. Who is that student? Students, among you, someone's mic on just before. Tell your name. Are you going to tell your name? I can get it, but you are going to tell me honestly who is there? स्टूडेंट्स कौन था? आई एम आस्किंग द नेम. Hope this is the first and last time. You don't do such types of mistake that each and someone is going to talk in background. So what you are going to listen if its noise is coming in this way? वीरेंद्र अभी तक क्या कर रहे थे? वीरेंद्र, आप किसी की आवाज नहीं आ रही. व्हाट हैपेंड? अब्दुल कलाम, आलोक.
Yes, sir.
अब्दुल कलाम,
Yes,
आलोक,
sir.
आलोक.
Yes, sir.
अंजना,
Yes, sir.
असगर,
Yes, sir.
अतुल. Asgar, your mic was on?
No, sir. No, sir.
So whose mic was on? Brahmanand,
Yes, sir.
Diya,
Yes, sir.
Itya,
Yes, sir.
Ipsita,
Yes, sir.
वीरेंद्र.
Yes.
मैं तुमको बुला रहा हूँ, तुम बोल क्यों नहीं रहे हो? Huh? When you have joined, I asked you, na, Mr. Virendra.
हाँ सर, माइक
Why
खराब था
your
सर.
mic खराब था, but now it is working. You must put a message over the message box that mic is not working. Yogesh, so tomorrow come you all and classes will be there offline, no online class. Okay?
Okay, sir.
You all are here. How many of you are here? कितने लोग हैं यहाँ पे अभी?
सर मैं अभी दिल्ली में हूँ सर.
हैं?
मैं अभी दिल्ली में हूँ सर.
सिंपल.
Yes, sir.
इतना लेट से क्यों ज्वाइन कर रहे हो?
सर वो नेटवर्क प्रॉब्लम हो रही थी.
तो अभी आपकी नेट अभी क्लासेस कोई ऑफलाइन होनी शुरू हुई?
सर वीएससी की क्लास ऑफलाइन हुई थी एक.
किसकी?
सर वीएससी की हुई थी सर.
किसकी क्लास?
सर जो एडिशनल कोर्स है उसकी क्लास.
ओके. तो एटलीस्ट यहाँ पे आते हो तो सब लोग जस्ट मेक इट शेड्यूल ना. एक्चुअली यू आर, इफ समवन इज कमिंग लेट, you don't join this class. If you are late, then you are late. 10 मिनट 12 मिनट इतना लेट आने से क्या फायदा है बोलो? It's a bad practice. Never ever do it this way. So what we are talking about, after drying the thin films is taken off from the carrier, it shows the screen printing techniques for the silver. Means here it has been taken the examples actually what materials is going to be used. So it is going saying that, for example, they are taking here that silver paste coating on substrate. The thickness of film depends on the solution viscosity, mesh, or you can say what your net diameter. Sorry?
Screen is not moving.
Once it is to be disturbed, then it is to be disturbed. So don't do it in this way. Otherwise you are going to be harmful. Now is it visible?
Yes, sir.
Okay. So the thickness of film depends on the solution viscosity, mesh diameter of the net, applied forces on the squeezer, and the velocity, how fast you are moving your squeezer on metal plate. So the above process is good with only one limitation, that thickness is not easily controlled. So it's always just you take care that whatever you are having, this is the substrate actually you are having, and this is the base. So what you are going to do, you are having this mesh, actually screen mesh is here. So this is the screen mesh, and you can say it's a screen net is here. What you are doing, you are actually pasting, you are putting the paste over here. And this is a squeeze, just you take out this squeeze from this side to this side. What is going to happen, this thickness is going to, it is going to it is going to inside the mesh, whatever the mesh it is having, and they are going to form a layers here. They are going to form, say, and if it is going to be put here, you say it's a between, this is the, you can say this is your size, say for its a thickness. So that thickness and these whatever the mesh, you can say mesh is to be given, that is going to perfectly they are, that paste is going to covered over this area, and that is going to control that how close you are putting this mesh and this substrate. So the distance between thickness between this distance and this mesh is going to control the thickness of your material sample, means your thin films. So that thin films are going to be prepared using this screen printing techniques. But you remember, this is the one way if you are going to take the metallic these chemicals of this screen printing you are using. Otherwise you can use the UV light also. If you are going to put the transparent materials here and UV light you are going to fall, they are also going to make a pattern here, and that pattern is going to be created within your substrate, and they are going to be used as and when you are going to use for the different purpose. So this is said to be the screen printing. This is the dip coating techniques. This is somewhere as good as the tape cast or the solution cast techniques what you have been studied. So in dip coating techniques, what actually you are looking, dip coating technique is a frequently used process at industry level due to its simplicity, low cost, and that a high quality film on both sides of the substrate can be obtained. In this process, the substrate is dipped into the solvent of which coating is to be done, and uses a small amount of liquid than spin coating techniques. Immersion, the substrate is immersed in the precursor solution of the coating material at a constant speed, preferably jitter-free. And second, deposition and drainage. The substance has remained inside the solution for sufficient interaction of the substrate with the solvent called the dwell time. So, and it is starting to be pulled up when the solution is in the rest state. The thin layer gets deposited on the substrate and is pulled up at a constant speed, leading to thin film formation. Extra liquid will drain from the surface, which removing the substrate up. The film thickness is easily controlled by pulling speed and density of particles, means viscosity of the solution and pulling speed of your substrate. Evaporation, the solvent evaporation from the solvent and thin films is deposited after drying it. Further drying can be done to remove the residual solvent. So what actually you are going to look here, you do have the solution in the same way as we have in the case of solution cast techniques or spin coating techniques or the tape casting techniques, whatever you have studied. Solution is likewise same, but what actually is going to differ in the case of spin coating, you have seen that you have put the substrate over a spin coater and it starts revolving here with a high RPM, and it is due to the centrifugal force the solution is going to cover whole surface of your substrate. Whereas in solution cast techniques, you have put it into the petri dishes, and in petri dishes it is going to form a, on slide, it is going to form a thin layer over here. Whereas in tape casting techniques, you are using the doctoral blade and it is going to just, you are moving one into other ends and you are going to form a control thickness film here. Where in this side, what actually you are having the solution, and what you are going to do, your substrate is going to be, first it is to be substrate and it's actually it is to be set in the machine itself. So what actually happening, it's slowly going down. Once it has been dipped, based on the solution viscosity as well as the quality of your substrate, what is going to happen, these materials are, solutions are going to get deposited on both sides of this substrate. you have to ensure that you are going to take it out quickly, or you have to give some time that is said to be the dwell time. Once it is going to deposited over this sample material, this over the substrate, then you are going to pull it back. Once you are going to pull it back, then what you are going to get it out, that these solutions are going to stick over the surface. Once it has been stick, you have to put in the vacuum oven for its complete drying. Whatever the solvent they are containing, they are going to get evaporated, and your materials are get deposited over the substrate on both the sides. So it is going to be used. So see, it's a very simple and robust process, and here it is going to be controlled. Thickness of these films are going to be controlled based on the speed of this substrate, how you are immersing and how you are going to pull it back. At the same time, on the basis of dwell time, how much time you have put into this solution, this substrate. So on this basis, you are going to prepare this using the dip coating technique. So here the 4 steps are involved. One is said to be the immersion, second is said to be deposition, third is said to be the drainage, and last one is vacuum drying, that is said to be the evaporation of solvent. One other technique is said to be the important technique. This is also, that is said to be the melt intercalation techniques. And in melt intercalation techniques, basically this is used in the case of polymeric materials. This technique is going to be used, as well as you can understand that it has been written here. Just you go through line by line, so you are going to get something. So melt intercalation technique is a standard for the preparation of polymer nanocomposite films. Is for the preparation of polymer nanocomposite films due to its advantages such as being environmentally friendly, absence of solvent, and low cost. It involves annealing the polymer matrix at high temperature, adding the fillers, and finally needing the composite to achieve a uniform distribution. One limitation is that high temperature may damage the surface property of nanofiller via degradation. So optimizations of thermal properties is important to obtain better dispersion of the nanofiller in the polymer matrix. This technique is better than solution cast method due to its lack of solvent. However, processing condition and surface modification of clay nanofiller compatibility of filler with host polymer play a key role in the dispersion of nanofiller. So what actually you have learned here? In this case, actually, whatever the preparation you are doing, actually, ultimately earlier what you are doing, earlier you are putting the polymer in solution, in the solvent to make it solution. Salt you are putting in the solvent and making it solution, and nano clay also you are putting into the solvent and making its solution. So all 3 solutions, what you are doing, first you are preparing this solution, polymer solution, then you are putting this salt into it, you are making the another solution too. Thereafter you are adding this nano clay here and you are preparing solution 3. So ultimately in solution cast techniques you are having the 3 steps for the 3 precursors. Whereas in melt intercalations, what you are doing, you are not using any solvent. Rather, you are mixing this polymer with salt, with clay in a powder form, and putting it at high temperature for the melting of this polymer. Once polymer is going to be melt, it is going to interact with all other precursors. So salt and nanoclay is going to interact once the polymer is going to be get dissolved. So, but at the same time, limitations has been put. Limitation is since some of the polymers requires high temperature in order to get melting. So for that purpose, it may affect the surface property of your nanofiller. So you have to take care of this, of the surface property of nanoclay or nanofiller. On that basis, you have to go ahead. Thereafter, the things are the same. This nanocomposite formations, you have to go through the, once it has been framed, then using the, like the hot press method you have seen, in that way you are going to prepare the thin films here using this melt intercalation techniques. If anyone have any doubts, then you can ask freely. तो इन तीनों टेक्निक्स में किसी को कुछ पूछना हो तो आप पूछ सकते हैं. किसी की है क्वेरी? Someone is there who want to ask something about this melt intercalations or the screen printing, or you say the third one what we discussed, that is the dip coating. So out of these three techniques, anyone have any query? Students, है किसी की query? या समझ में नहीं आया? I have to repeat it. Students, if you are not going to say something, then what I am going to know that you are getting or not? Students, if not, then I'm considering that you all are getting the points. Now I'm proceeding ahead about this chemical vapor deposition techniques. In chemical vapor deposition techniques, just you see, it is a chemical process used to produce the high purity, high performance solid materials. The process is often used in the semiconductor industry to produce thin films. Chemical vapor deposition technique is a generic name for a group of processes that involves depositing a solid material from the gaseous phase. In typical CVD, the vapor is exposed to one or more volatile precursors which reacts and are decomposed on the substrate surface to produce the desired deposit. Frequently, volatile byproducts are also produced, which are removed by gas flow through the reaction chamber. So, on the basis of the way how you are going to flow your this reactive precursors, the nomenclature of this CVD techniques has been changed. If you are using all the sending this reactions precursors at atmospheric pressures, then it is used to set to be the APCVD, atmospheric pressure chemical vapor deposition techniques. If you are using a vacuum and it is low pressure, then it is said to be the LPCVD. If you are using the metal organic precursors, then it is said to be the MOCVD. If you are taking the plasma assisted, means plasma, you are taking the help in doing this chemical reactions on the presence of plasma, then it is said to be the plasma assisted chemical vapor deposition or plasma enhanced chemical vapor deposition, that is said to be the PECVD. If you are doing this on the presence of laser, then laser chemical vapor deposition. Photochemical if you are using, then photochemical vapor deposition. Chemical you are using chemical vapor deposition technique, and chemical beam epitaxy it used to say. I'm not talking right now this one. So what you found here, since ultimately you have to prepare whatever the precursors you are having, those precursors has to be converted into vapor. That is the important criteria, that whatever the whatever you want to deposit over any substrate, then those materials need to be first converted into the vapor. So this conversion of vapor, whatever the method you are opting, accordingly this nomenclature is going to be changed. But what happens once these vapors are going to be formed, you have to work out some reactive gases also, by which it is going to come and deposit over the substrate. So if you see here how it works, then it is to be precursors gases. Whatever precursors gases are there, whatever the precursors materials are there, you have to first prepare their gases, often diluted in a carrier gas. So some carrier gases are going to be used. It may be the inert, may be the useful for your precursors. So are delivered into the reaction chamber where you are doing actually these reactions at appropriately ambient temperature. So as they pass over, come into contact with a heated substrate on which you are going to deposit it, they react or decompose, forming a solid phase which and are deposit onto the substrate. The substrate temperature is critical and can influence what reactions will take place. So what are the typical characteristics are there? So they are maybe the fine grain, impervious, high purity, and harder than the similar materials produced using the other conventional techniques. So CVD coating are usually only a few micron thick and are generally deposited a fairly slow rate. So usually of the order of a few hundred micron per hour. So just you see how lengthy this technique is. So you have to be very patient in order to grow your materials using the chemical vapor deposition technique. So just you can see schematic diagram here, that whatever the source materials you are having, that is, I used to say precursors, whatever the precursors you are having, those precursors vapor need to be created and it has to be flow with the help of carrier gases. So once they are going to enter here, this compartment, this is the reactions compartment, reaction chambers. Here, whatever the atmosphere you are going to create, that atmosphere is going to say their CVD names. So a chemical vapor deposition operator will consist of several basic components. First is said to be the gas delivery system for the supply of precursors to the reaction chamber. Here, this is the first step. In the second step, reaction chambers are there, chamber within which deposition takes place. Third one is substrate loading mechanism. These are the substrate here. So how it is going to get deposited over the substrate, those reactions gases. So a system for introducing and removing substrate, this mandrels, etc. So energy sources provide the energy heat that is required to get the precursors to react or decompose. Vacuum system requires in order to a system for removal of all other gaseous species other than those required for the reactions deposition. Exhaust systems are required, that systems for removal of volatile byproducts from the reaction chambers, whatever being the unnecessary particles left that need to be get evacuated. Exhaust treatment system, in some instances exhaust gases may not be suitable for release into the atmosphere and may require treatment or conversion to safe harmless compounds. Process control equipment, gauge, control, etc. to monitor process parameters such as pressure, temperature, and time. Alarm and safety devices would also be included in this category. What are the energy sources? It may be the resistive heating, it may be the radiant heating, it may be the radio frequency required, it may be the laser, or maybe the other energy sources in order to create the vapor of your precursors. So these are the energy mechanism may be used in order to create the vapor of your precursors. So what are the precursors normally people used to take? Materials are deposited for the gaseous state during the CVD. Thus, precursors for CVD processes must be volatile, but at the same time stable enough to able to deliver to the reactors. Generally, precursors compound will only provide a single element to deposit materials, with other being volatile during the CVD process. However, sometimes precursors may provide more than one, such as materials simplify the delivery system as they reduces number of reactants required to produce a given compound. So typical materials, just you note it down that these are the typical materials which are going to be deposited using the chemical vapor deposition process. So I'm going to stop here. Next class, I'm going to start with the different aspects of this chemical vapor deposition technique. If anyone have query, you please ask. Otherwise, I'm going to leave the class right now and you come for your attendance. Have any questions? Students, any questions you are having? आपकी आवाज नहीं आ रही है. What happened? सारे के सारे बच्चे you are completely silent. What the you are you getting the things or it's the just you are passing your time? Students. आलोक.
Yes, sir.
तुम लोग की आवाज क्यों नहीं आती? जब भी कुछ पूछते हैं तो आवाज क्यों नहीं आती है? हैं? क्या बात है? अंजना,
Present, sir.
अटेंडेंस के लिए इट्स ओके, बट व्हाई यू आर नॉट, तुम लोग कुछ सुनते भी हो कि नहीं जब चीजें पढ़ाई जाती हैं? हैं? कि समझ नहीं आता बिल्कुल? अंजना,
Yes, sir. I understood, sir.
असगर,
Yes, sir. Yes, sir.
व्हाट हैपेंड? नो वन
ठीक
इज
है, सर,
स्पीकिंग
अच्छा।
एनीथिंग.
सर क्लास ठीक था सर, समझ में आया सर।
अतुल, व्हाट हैपेंड? ब्रह्मानंद,
Present, sir.
समझ में आ रहे थे यही बात जो यहाँ पढ़ाई जा रही है?
Yes, sir.
अब्दुल,
Yes, sir. Present, sir.
दिया,
Yes, sir. Present, sir.
इप्सिता, कल्पना,
Yes, sir. Sir, Ikshita present.
इप्सिता प्रेजेंट, कल्पना, कुलदीप,
Sir, Kiran present, sir.
किरण, कल्पना आफ्टर दिस किरण, ओके. कल्पना इज नॉट हियर. कल्पना इज देयर. ओके. मगन,
Yes, sir.
तो आप सब रेडी रहना सरप्राइज टेस्ट के लिए. कभी भी सरप्राइज टेस्ट आपका हो जाएगा. 2 सरप्राइज टेस्ट हमें लेना है. एंड थर्ड वन इज गोइंग टू टेकन बाय कमलेश, डॉक्टर कमलेश. So you keep in touch with him also.
सर सब्जेक्टिव होगा, ऑब्जेक्टिव होगा सर?
अभी तो देखते हैं कैसे है सिचुएशन. अभी तो नहीं कुछ कह सकते हैं. तो
ओके सर।
अगर ऑब्जेक्टिव होगा तो आपके पास आ जाएगा. ऐसे वो भी सरप्राइजिंगली आएगा. तो जस्ट रिमेंबर रिगार्डिंगली ना, मैं बताने वाला नहीं हूँ कब आने वाला है. मुरली,
Yes, sir.
नमिता, नमिता इज देयर.
Yes, sir.
नवीन,
Present, sir.
रोहित,
Present, sir.
रोशन,
Present, sir.
सागर,
Present, sir.
सारंग, सिंपल,
Present, sir.
सौरभ, सुप्रभा, हर्षिता,